Hello, my name is Muhammad Nazmi Ashraf bin Muhammad Tamin. I will presenting for part 1, which is construct appropriate graph or chart to compare the relative frequency and cumulative relative frequency between the two key performance indicators. Before we construct the graph, the first thing we do is we need to distribute the frequency on the data into two classes. For example, 10.0 until 19.9, and then record the frequency into each classes. After that, we calculate the relative frequency and cumulative relative frequency. To find the relative frequency, we need to divide the frequency of each classes by the total number of frequency. For example, 3 divided by 30 we got 0.1, and 7 divided 30 we get 0.23. Continue same with all classes. For cumulative relative frequency, we need to add all the previous relative frequency into the current relative frequency and the next relative frequency. For example, 0.10 plus 0.23, and we get 0.33, and 0.33 at 0.23 we got 0.43. Continue similarly with the next number. It is also the same process of creating the work schedule for profit margin. This is the graph for production cost and profit margin. The first the relative frequency for production cost, the most range are similar, that is around 0.1, except of the 20 to 29.9 million range, which is higher at 0.23. While for the profit margin, most of the value are between 20 to 29.9, which is the highest percent, that is 77%, while other are between 10 to 12%.
My name is Tin Chong Hua. My metric number is BB233030915. For the production cost of cumulative frequency, the curve shows a steady increase which is in range 90.0 until 99.9 at cumulative frequency at 1, indicating cumulative growth in the proportion of production cost. For the profit margin, the curve rises sharply and faster between 10.0 until 19.9% and 20.0 until 29.9%, indicating a large portion of data falls within this range. The increase slow after 30.0 until 39.9%, reflecting fewer occurrences in the higher profit margin. As the comparison between production cost and profit margin, both relative frequency and cumulative frequency for production cost show a more even distribution after interval. For profit margin, the majority of occurrences are concentrated in one range, which is 20.0 until 29.9%, leading increase in the cumulative frequency.
Continue to part 2, but before that, let me introduce myself. My name is Intan Nur Adawiha binti Norman with number matrix 2311053N. The part I will be presenting today is part 2, which is measures of central location. Measures of central location is finding mean, median, and mode. But to get a correct answer, we should be arranging the sample data in ascending order. We can arrange it from the lowest amount to the highest amount. As you can see in the slide, I've already arranged the sample data for production cost and profit margin. The total for profit margin is 1,484.2. And the total for profit margin is 741.7. Next is how to find mean, median, and mode. Mean is calculated by summing all the values in the dataset and dividing by the numbers of values. Next is median. Median is the middle values from the dataset that are ordered from the latest to the greatest. The last one is mode. Mode is a data that frequently appears in the dataset. So for the production cost mean is 49.47. To get the answers, all the datasets should be arranged from the lowest to the highest and divided to the number of company, which are 30. The median for the production cost is 46.25 and the mode is 36.2. For the profit margins, the mean is 24.72 and for the median, it is 25.35. But for the mode, it is slightly different because it has 6 data that are frequently appears in the dataset, which is 21.2, 22.1, 23.3, 26.3, 27.6, and 30. Each of these data appears 2 times. Indicators for comparison in measuring central location is median, especially in datasets that are imbalanced or contain outliers. Median also provides a more reliable measure of central tendency in such cases. The best situation for using mean, median, and mode are: for mean, it is best used in normally distributed datasets without significant others. As examples, test scores. For median, median is best used for income data where a few high earners can distort the mean. The median provides a better representation of typical income level. Mode is more suitable in the categorical data example, identifying the most popular product size sold in a store and analyzing survey responses where certain answers are more frequent. That's all from me. Continue to part 3.
Continue to part 3, but first let me introduce myself. My name is Mercy Milik and my metric number is BB233010624. Part 3 is the part where we need to calculate the percentiles and construct a box plot. To calculate percentiles, we must first organize all the data so that we can find the specific data point that we need, which is the minimum data, maximum data, quartile 1, quartile 2, which is the median, and quartile 3. The minimum value represents the smallest data point, while the maximum value represents the largest data point. While a quartile is a statistic method to divide a sorted data set into 4 equal parts, each contain 25% of the data. It helps analyze data distribution and identify outliers. The 3 quartiles are quartile 1, which is the value at the 25% percentiles that's separating the lowest 25% of data, while the second quartile, as known as the median, is dividing the data into 2 equal halves, which is the 50 percentiles. Third quartile is the value at the 75 percentile, separating the highest 25% of data. As we can see in the slide, I already calculated the necessary data to find the production cost percentiles and the profit margin percentiles. For the production cost percentiles, the minimum value is 11.8 and the maximum value is 97.2. The value for quartile 1 and quartile 3 are same, which is 26.45, while the median is 46.25. As for the profit margin percentiles, the minimum value is 16.3 and the maximum value is 31.2. Quartile 1 is 21.88 and quartile 3 is 27.6. For the median, it is 25.3. We'll talk about the production cost box plot and profit margin box plot. As you can see in the slide, for the production cost box plot, the data spread between a minimum of 11.8 and a maximum of 97.2 million. The IQR, which is the interquartile range, middle of 50% of the data lies between 26.45 and 67.7 million, while the median slightly skewed towards the lower end of the interquartile range, indicating a mild asymmetry in the data distribution. The whiskers, which is the lines extending beyond the box, indicate that there's no extreme margin box plot. The profit margin is centered around 25.35%, with most values falling between 21.88% and 27.6%. The distribute appears to be relatively symmetric, as the median is near the center of the box. There is no extreme variability in profit margin, as the whiskers are not overly long, because most values are pretty close to each other.
Continue to part 4, which is measures of dispersion. So hi, my name is Jovinia Janejuin and my number matrix is BB233110679. Measures of dispersion quantify how spread out or variable set a data is providing insight into the consistency and predictability of business metrics. So as we know, there are 4 types of key of measures dispersion, which is range, mean absolute deviation, variance and standard deviation, and the last one is coefficient of variation. So in this case, we need to calculate the range of production costs and profit margins. The formula for range is maximum value minus minimum value. So as we can see in this slide, the production cost range is 85.4 and profit margin range is 14. Number 2 is mean absolute deviation, which is known as MET. To calculate the MET, we use the sample formula, which is sum up all the values and divided by the number of all values. So in this calculation, we need to find the mean first. To find the mean, we need to sum all of the data, and then when we get the answer, we need to divide it by the number of data. After that, we need to sum all of the data again and divide it by the number of data. As we can see here, the production cost math, I only get 21.65, and for the profit margin math, I get 3.10. And for the number 3 is variance and standard deviation. For this calculation, we need to use the sample formula, which is for the variance, we need to calculate all the data by the power of 2, and then when we get the answer, we need to sum all of the value, and we need to divide it by the number of data. And for the standard deviation, we need to use square root. For this slide, we can see here the production cost 50.47%, and for the profit margin we get 15.02%.
Hello, my name is Marvila Larau. Matrix number BB233111131 will be continued for part 5. Is a measure of associations between the two key performance indicators. Firstly, I will calculate the average values, production costs, and profit margins, so that you can see the formula at the slide and the calculation, the x and y. Sum x equal 1484.2, then x equal 1484.2 division 30 equal to 49.47 millions. And then for sum y equal 741.7, then y equal 741.7 division 30 equal to 24.72%. I compute the covariance to assess how these two variables vary together. Formula is cov xy equal to sum x sub x, y sub y division n. X, the covariance is negative 83.7. Calculate the standard deviation. For production cost, x is 24.99, and for the profit margins, y is 3.74. Calculate persons correlations coefficients, which tell us the strength and direction of the relationship. For example, for company 1, the production cost deviation is negative 5.77, and the profit margins deviations is negative 1.42. Correlations value are equal to negative 0.897. There is very strong negative relationship between production costs and profit margins. Conclusions: high production costs may lower operating efficiency or increase the fixed cost burden, resulting in smaller profit margins.